2.6a is on page 91. Actually understanding what's going on in chemistry really relies on you having an understanding of what's happening smaller than you could see with a microscope, right? So we call that at the particle level. So even with a microscope, you cannot see these particles. But if you zoom in so close, you can then, you know, pretend that we can see them and we can draw them. And so these exist in our imagination, but they're also actually real things. They're just too small to see. There are 4 types of particles. If you have a single element, just one atom of an element, then that is just an atom. I don't know how to describe it any better. It is the smallest piece of matter that is still got the characteristics of that element. You cannot break an element down any further than a single atom, okay? And atoms have a neutral charge, which means they are not positive and they are not negative. So they have a neutral charge. They are not positive or negative. You can have a molecule, okay? And how does a molecule compare to an atom? Like, what's different about a molecule compared with an atom? Yeah, it's at least 2 or more atoms stuck together. So you need to have 2 or more atoms. And they are stuck together. Do you guys remember the term covalent bond? Okay, this bond here is a covalent bond. If I was to ask you for different kinds of elements, what categories could you put elements into? There's 2 big categories for elements. Everybody think about it. What are the 2 big categories for
metals and nonmetals?
Metals and nonmetals. What do you notice about the atoms in that molecule? What type of elements are they?
Both nonmetals.
You know? Yeah, they're all nonmetals. Molecules are made exclusively of nonmetals. Nonmetals only. Our 3rd type of particle is an ion. Now, ions can be a single atom with a charge. That is called a monatomic ion. Mono means 1, so monatomic, 1 ion. Do you remember what we call it when we have more than 1 atom in an ion? Do you know the prefix for many? Poly. So this is a polyatomic ion. And the interesting thing about polyatomic ions is they are actually, the atoms in there are actually held together by covalent bonds. Because you'll notice you've got a nonmetal and a nonmetal, and they stick together by a covalent bond. The newest one is called a formula unit. You've probably not heard of that before, but a formula unit is made of a positive ion and a negative ion together, because positive ions can't actually exist on their own.
You're
In
cutting out
nitrogen,
a lot.
If you took a whole bunch of sodium ions, Na+,
It's frozen. Yeah.
and tried frozen. Well, you can just listen to me. Can you hear me? At home? Is the talking okay? Okay, I'm just talking, so nothing's happening right now, okay? It cuts in and out, that's fantastic. Okay, my apologies. If you tried to put a bunch of sodiums right beside each other, putting a positive beside another positive beside another positive, what do positives do to positives? They repel. So anytime you have a positive ion, it needs to be balanced out by a negative ion so that you don't just have the matter like exploding all over the place, okay? So a formula unit is a positive ion and a negative ion together. This is the smallest possible unit of an ionic compound. Hence the term formula unit. We cannot call it a molecule. Why is that formula unit not a molecule? It does not have a covalent bond, and because they're not nonmetals. I have one nonmetal and one metal. So if I have a metal and a nonmetal, that is going to be a formula unit. So here we have a metal plus a nonmetal. I'm going to guess that if I scroll down here, everything I've written here is probably on the document down below. But let's see. Let's see if I remembered everything up in just this top little section here. I probably missed a few things. The original one, the Tom Lehrer one. Thulium and thallium. It's to Modern Major General. Have you guys ever heard that song? Oh, well, we'll have to play that at some point. Okay, atoms are neutral. They are the smallest component of an element. We talked about that, although we didn't write it down. And they can be metals or they can be non-metals. We will deal with metalloids in the next unit. So for now, you can just pretend they don't exist. Okay. We have a lovely staircase. Do you see the staircase? Do you remember the staircase? Okay, if you don't, the non-metals are on the right of the staircase. And then the metals are everything to the left of the staircase, except who's special? Hydrogen is special. Hydrogen is a non-metal. So if you're looking at the non-metals, they're all on the right-hand side, except for hydrogen, okay? And any periodic table I give you will have the staircase on it, okay? And I guess while we're here, we're going to just note that this very last column, okay, this column right here, those are called the noble gases. We'll go over other groups later, but this one we're going to talk about right now, so we might as well know that those are noble gases. So what are these atoms busy doing? What is existing as atoms? Because there are things that exist as atoms rather than existing as a molecule or as a formula unit. So what is it just hanging out as atoms? Well, first of all, most of your metals just hang out as atoms, okay? And they form regular arrangements, so they actually form crystals, okay? So they just stack one on top of the other in like a 3D structure. There are different ways of stacking. You can see in the purple figure, everybody's sort of stacked like a little snowman. Yes, one on top of the other. Whereas with the red one, they're sort of like, you know, offset one, okay? Doesn't matter. Those are still atoms and they are solids at room temperature. We are these are held together. The atoms are held together by metallic bonds. And you don't need to know a whole bunch about metallic bonds right now. I'll give you a quick description, but we're not going to go into detail and you're not responsible for it. Basically, in the middle of your metal atom, you have, what is in the middle of every single atom? In the very middle of every single atom in the universe, a nucleus. And what charge is the nucleus? It is positive. Why is it positive? Because there's a bunch of protons there. Okay, what is around the nucleus? Electrons. And do you remember how those electrons are arranged? In shells. Okay, so there's those shells. You remember the Bohr model. That very outer shell is called the what? Valence shell. Don't worry if you forget these names. They're coming up in Unit 3. This is just a preview, okay? Electrons that are in the very outer shell in a metal are held very loosely because they're really far away from that positive nucleus. Negative things close to the nucleus are held really tightly. Negative things that are far from the nucleus are much less tightly held. So if you have some metal atoms, right, if I just drew a row of metal atoms, you can think of them as having this sort of core that's positive, okay? And then your valence electrons are actually free to move because they're not held super tightly. They can actually move to the next atom. And if it moves to the next atom, then this electron has to kick over to the next one. And then this one would have to kick to the next one, and so on and so forth. And that's why metals conduct electricity, because those valence electrons aren't held very tightly and they can move from one atom to the next, okay? Again, you don't need to know the details of that. That's just for your information because it's fun. So all metals are solid at room temperature. You should know that, except for who? Mercury. Mercury is all kinds of weird. We'll discover more about why Mercury is weird later. Okay, so this is mercury and it is a liquid. It's still held together by metallic bonds. It's just the metallic bonds aren't as strong, so the particles can slide past one another. They're freely moving. Okay, yes? Yes. So the thermometers that we have, just to be clear, do not have mercury, okay? The red liquid is not mercury. But what happens is with mercury and with the liquid that is in our thermometers, which I think is alcohol, but I'm not 100% sure. When temperature increases, what happens to the individual particles? They start moving and they start moving faster, yes? And when particles start to move faster, you can imagine if I had you guys like all in a cluster, which would make for terrible COVID practice, but let's say I had you all in a cluster and you were like a solid and you just were like jiggling, right? Because that's what solids do. Oh, I should turn on my video camera here so you guys can, at home, can watch me like behave like an idiot. Are we there? Oh, no, there I am, hello. Okay, so the little solid particles are just jiggling, all right? And then they start to move, right? And they're moving kind of slowly so they don't take up a lot of room. But when they start to move really fast, and if only you can't see me because I'm running back and forth from one end of the classroom to the other, yes? Because they're moving so fast, they end up taking up more space, and the space between the particles gets bigger. And so then the mercury will rise because it's taking up more space. Did that make sense? Yeah? Cool. All right, that was an excellent question. Now, where else do we find atoms in nature? We will also find them as non-metal elements. The only ones that are atoms, only the noble gases exist as atoms. Does anyone know how some of our other gases exist? Like say oxygen.
Diatomically?
It's diatomic. So if you have, this is, maybe this one is, say this is argon. Okay, we would just write it as argon gas. But if you have nitrogen, it's diatomic. So instead of existing as atoms, the diatomics exist as what kind of a particle is this? What kind of particle is this right here?
Molecule?
That is a molecule. And that means in between those particles, what kind of a bond do we have? That is a covalent bond. And those nitrogen and nitrogen, I guess they have to be both nonmetals. If one of them is a nonmetal, the other nitrogen must also be a nonmetal. Some nonmetals exist as big structures, carbon in particular. Carbon has the ability not just to form one bond or two bonds or three bonds, it can form 4 bonds. Okay, and what I have here, this is my diamond, which I hope nobody steals, right? How valuable it is to me. And what we've got here is a 3-dimensional array where every carbon is stuck to 4 other carbons. 1, 2, 3, 4. All right? And those are covalent bonds, and covalent bonds are super, super, super strong, which is why diamond is one of the hardest substances that you can come across, because every atom is covalently bonded strongly to all of its neighbors. Yes, yes? Okay, so that's why carbon is a solid. It either comes as diamond, it can also come as graphite. I promise if you're at home right now and you're like, I can't see what these pictures look like, I will show it again to you tomorrow. But graphite has layers, all right? How many layers does this graphite have? 3, yes? 3 layers? Hopefully at home you can see there's like 1 here, and 1 here, and then 1 up the top. And within the layer, everything is covalently bonded. So you have quite a strong sheet, okay? But in between, they're just held together by weak forces, okay? And so that's why graphite is what your pencil is made of, yes? Can you imagine that this is a pencil and that my hand is the paper? When I write on the paper, the bottom layer will stick to the paper and actually shear off. So if you can imagine, this layer gets sheared off and it breaks away from the rest of the layers. Yeah? Again, do you need to know that for this test? No, but it's really interesting and it will become important later on. You can't hear me. Oh no. Paper. Paper is made out of cellulose. Okay, here, hang on. I am screen sharing. I am not muted. Cellulose. Can you hear me now? Yes. Okay. Don't worry if you missed the last couple minutes. It was me babbling about like mega covalent networks, which I get really excited about, but aren't actually part of what you have to learn in Chem 11. So if you missed it, don't worry. If you want to ask me about it tomorrow, you can. Okay, molecules. And I think this is all we're going to get through today because we're almost at 2:25. Do you mind if we go a couple minutes over? Just to get through molecules? We're okay with that? Okay. Molecules are neutral. Molecules are neutral. They have no electrical charge. They are made of nonmetals only. We said that before. They must be made of 2 or more atoms, and they are bonded covalently. We said that before. What does it mean to be bonded covalently? It means they share their electrons, okay? And what that's going to look like, and maybe this will be the last thing I teach for today, is that if you have a hydrogen atom, we're going to use hydrogen because it's the simplest. It's got 1 proton, yeah? Around that hydrogen is 1 electron. Am I gone again? Can you hear me?
We can hear you now.
Okay. So it's got its 1 electron. Okay, can I repeat what I said before? The atoms are bonded covalently and they share electrons. Is good? I've just basically been reading this little bit here, so that's about it. We're going to look at hydrogen. Okay, this is a hydrogen atom. Okay, and I'm actually going to take a hydrogen atom and bond it to another hydrogen atom. I kind of ran out of room here at the top. Okay. Each of these hydrogen atoms has an electron. What charge are electrons? They are negative. And what does negative do to positive? It attracts. So you actually have an attractive force between the proton and the shared electrons. So hydrogen A's proton attracts the shared electrons, and hydrogen B's proton attracts the shared electrons, and that's the glue that holds a covalent bond together. Okay, and we are at 2:25, and I feel like we should be done at this point. Yes? So we're going to leave it there. Your homework, let me find a new page for this. Homework, anything you didn't finish on pages 12 and 13? You are going to finish page 22, 23, 22? I think it's 22. 22. And let me just see if there's anything from 6A I want you to do. You could do page 95. And I don't want you to do the whole thing yet, but you could do number 1, 2, 5, 6, and 7. And we'll just leave it at that for today. You also have your lab, which is due on Friday. If you have any questions about the lab, do stay today and ask about them if you're in group B, because this is the last time I see you. I had people get 4 out of 10 on this lab last quarter. I had people get 3 out of 10. Why? Because they didn't know what they were doing and they didn't ask questions. If you know what you're doing, or if you've asked the questions already, good, you'll probably get 10 out of 10. But if you have questions, make sure that you ask them.